So when we work on these ones here,
Stop it.
I gave you guys the inequalities to set up, so hopefully it wasn't so bad. Obviously, we cannot have negative values, so your A greater or equal to 0, B greater or equal to 0. One thing that when you go through this stuff, we have, I went A's first, then B's. Cover and solves, you get, I didn't fill in the last bit here. It's 3A plus, was it 6B?
No, yes.
And then it's 75 and 50, and this one was the 18, right? Yeah. So when you cover and solves, you get 20 and 10. You move it inward. The next one, when you cover and solve, you get some other numbers. 8 and 12. 12 on 8. 12 on the other, right? I have that. It helps if I have my notes in front of me sometimes. Guys. So you have an intersection point right there. Bless you. The very easiest way in the human nature to set this one up, divide everything out there by 3, you get A plus 2B is 20. So A is 20 minus 2B. Substitute that up here. When you solve that system, then you get an ordered pair of 2, 9. Good. Well, if you were 9, 2, then that means your A values were the vertical and your B values were horizontal, hopefully.
Oh, yeah.
Then you're fine. Then you just substitute back into your constraint, excuse me, not constraint, but your objective function. I know what it's called sometimes. And you should wind up with 2, 9 being your maximum. Okay? That's what I had. The next problem. The next problem is the orange aid. Ladies and gentlemen, come on. We got enough of this stuff to go through today. Talking about 2 types of juice, orangeade and berry fruity. 1 gallon of orangeade is made by mixing 2.5 quarts of orange juice, 1.5 quarts of raspberry juice. 1 gallon of berry fruity is made by mixing 3 quarts of raspberry juice and 1 quart of orange juice. Blah, 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 blah. It asks you to maximize, how many gallons of each type of juice should be made to maximize profit? Excuse me. So you go through the whole problem, you will recognize that you get a profit value of 50 cents for the orange. I'm going to use OR. And you get 40 cents a gallon on the berry. And that's your objective.
Oh.
Okay? After that, you have orange juice and your berry fruity. Well, this is where I told you guys, they're talking about you have so many gallons on hand, but they're mixing it in terms of quarts. Convert your gallons to quarts. All right, so you had, it wound up being 500 gallons of the orange juice. Do I have that backwards? Oh, 600? Okay, so it's 500 of the, okay, of the raspberry juice. So you get, when you put that together, you get 2.5 in the orange plus 1 in the berry fruity. I'll use a little bit again. And then the other one is 1.5 in the orange and 3, and that's going to be less than or equal to 600.
It should be 6.5.
1.5
It should be 2.5
Why
orange.
is it 600?
Yes, 2.5 orange plus,
No, 'cause 600 's
1.5 berry.
600 is the 2.5
What's
is
the 500 and 600?
Yeah, where'd the 600 and 500 come from?
the 500
multiplying 100 by, multiplying your 150 by 4 and your 125 by 4 to get quarts. It's 125 gallons of orange juice. One of them uses 2.5 quarts of orange juice, and the other one uses 1 gallon of orange juice. That's right.
Oh,
So I can like the math.
Yeah, this is right. Because one of them, this is the orange juice line, what you're using for orange juice. This one is the raspberry juice.
where did you get the 500 and 600?
Multiply.
Well, I've already said this 4 times, multiplying gallons by 4 to get quarts. I told you that yesterday, you have to multiply gallons by quarts. Otherwise it won't work. Sir.
So what I did was I took a different approach. I put it in fractions, so like, you know how it was.
Why would you do that?
I don't know.
It's okay, but yeah.
So I had something like 5/8
Okay.
x plus 1/4 y, and then or less than or equal to 125.
Alright, it would have worked.
Yeah, yeah.
It's just god awful ugly.
That's what
Did
I
you get the
had.
right answer?
I used that 20 years.
I didn't. I said, "What is this?" And I stopped.
That's well done.
Then I got to intercept at 200. Yeah, it just.
You get the same thing, but oh, good for you.
See,
One of the tricks of these types of things is that if they give you something in decimal, keep it in decimal. If they give you something in fraction, then go fraction. But in this case, they gave you something somewhat decent in fraction in decimal form. Because when you go to find your intercepts with these decimals, it works out pretty decently. Instead of you having to go through and multiply by reciprocals and all that, you'll get it. That's a glutton for punishment right
Mike,
there.
what would the fridge do, man?
The phrase would have multiplied, man.
The fridge would have said,
To the heck with it and got rid of all the decimals, multiplied everything by 10.
The fridge
I
wouldn't
don't
have done
even
it.
want
because
any
he's the
juice,
fridge.
is what you should say.
Yeah, I know you wanted to juice.
I want that chicken.
Anyway, and then you've got to be greater than or equal to 0 for one. Yeah, it is pretty terrible. Orange.
I didn't read it like that.
All right. So when you write these out,
Guys,
I have my orange juice on the X and my berry over here. I have the first equation, I've got 200, 500. Working inward. The next equation I have 400, 200. I have an intercept here. Now, when I work with the intercept on that one, once again, it is setting you up, since you have b with a coefficient of 1, use substitution. b is 500 minus 2.5 orange, and substitute that into here. So you get 1.5 orange plus 3 times the quantity, 500 minus 2.5 orange, and that has to equal 600. Remember, when you're going to set up to solve the intercept of the two lines, you use just a plain old boring equal sign. You don't worry about inequality because you're solving the system at this point. So with a little bit of arithmetic and a little bit of luck, you should get orange at a 150. And when orange is 150, you substitute back in, you wind up with a berry ordered pair of 150 to 125. Now, if your fractions worked out okay, you should have gotten the same point.
They probably didn't.
But here's the thing: this is in quarts, and if you kept everything in terms of gallons, are you at?
Yeah, I got the same thing as that. I messed up the graph though, but it should look like mine should.
Okay. What's your order pair then is probably what? You divided everything by 4, so you're
I still got 500, 200,
okay.
200, 400.
Okay. I go for your intercept and stuff like that. Yeah, you're going to get the same intercepts, even though you change. Because what you're doing is you're multiplying by a scale. You're doing scalar multiplication on an equation, so it works out just fine. So then when you put in your 4 points there, you have 0, 0, 200, 0, 150, 125, and 0, 200. You'll wind up with your maximum at that 150, 125. Hopefully. All right.
Remember, we have fun today, right?
Yes, we do. And then the last one. Last one was a little bit weird. Did anybody get a really weird decimal that said, "Oh no, I'm doing something wrong"?
Four.
For the last problem, 4 something? You did just fine. You got it right.
Really?
Yeah. Can you have 4.5 gallon or 4.5 jars, 4.6 jars?
Yeah, you could.
You can't. You gotta just, you round it down, and that's one of the weird things that happens. And my idea, if you got the 4.6 and 4 point something and change, you did the problem perfectly. You did a great job. That's a tough problem, so good work. What'll happen is on these problems with that extra line that without a pair of intercepts, without being in standard form, if I give you something like that on a test or a quiz, that'll work cleanly, okay? It'll work cleanly. It won't give you that decimal that you go, all right? It'll be a clean number on that one. So let's look at that one real fast, because I think today is going to be our last day doing this stuff, which I'm sure you guys will be devastated with.
Yeah, I didn't get it.
This might be on
I
parallel.
got two parallel lines and I ain't going through them.
Parallel lines. Something ain't right here. Home canning. So you're canning tomatoes and onions. You have a total of 180 tomatoes and 15 onions. So you have 180 tomatoes and 15 onions. Your tomato sauce, we use little t. Your tomato sauce uses 10 tomatoes and 1 onion. The salsa uses 5 tomatoes and 1/4 of an onion. That's really boring salsa.
It tastes good.
You make a $2 profit on tomato sauce. You make $1.50 on salsa. Yeah, it's a 5 in there. Oh, yeah, thank you. I said quarter, didn't I?
Yeah, but you wrote two.
Thank you. It's close enough. And obviously you can't have negative values, so T and S are greater than or equal to 0. But the weird one is going to be, it says you have to have, what it said, they want it at least 3 times as many jars of tomato sauce as salsa. So that means your tomato has to be greater than or equal to 3 times your salsa. You want 3 times as many, so the tomato sauce has to be greater than 3 times as many salsas. So if I have 1 jar of, yeah, it's a weird one. And it gets a little tricky. So you've got those guys to worry about. Now, by making this quick little chart here, these are what you're adding together. All right. So you wind up with the following. You get 10t plus 1 onion. Excuse me, I'm going to use S so it doesn't look like an O-N anymore. For less than or equal to 180. That's how many tomatoes. Not tomatoes, I'm sorry. Yeah. And then it uses the, it's 5S. I read the wrong line on my notes, I'm sorry. 5 in the salsa, excuse me. I have it written 4 different ways here, okay? Now you have 5 tomatoes and 1/4 onion. I keep reading the wrong line. I gotta remember I'm right here now. Done these problems so many times, it's ridiculous. You think I'd have it memorized. I don't know. So here's your parameters. And then your objectives to maximize costs. And then we plot. So when you plot this one out, you wind up with intercepts. The first set of intercepts are 18 and 36. Working inward. Then we have 15 and 75. And we're still working inward. Now, what I did right away, before I worry about the third line to draw up, I find that intersection of those 2 lines. Now, by doing some quick math here, you're going to get T is 15 minus 0.25 S. Substitute into here, solve for S, you wind up with an ordered pair of 12 Do you agree?
Yes, sir.
Alright. Now, the weird one. If I'm going to be looking at that point 12, 12, what I'm going to do is just drop the 12 down on the x, or the t-axis, if you will. So I test it here. If t is 12, where's s going to be? 4. Very good. Everybody see that? 12 equals 3 times something. That something is 4. Do you agree? So that means if it's at 12, is it going to be above or below this point? It's going to be below that point. So it's going to be going through something like that. And do you see why you had yours up above? That's how you test it after this spot, by just looking at it as a quick substitution in. Now what you did would have been fine. Now I know that this one's moving up here, so I have to worry about this spot now. And in order to find that spot, I know that that's where this guy intercepted. Oh, I'm sorry, it's supposed to be this down here. Where it intercepted the 75 and 15, which is this one. So you find that ordered pair just by substitution. And that's where you get 3 1/4 S is 15. So you had salsa at 4.6 something. You can't have 4.6 jars of something. You don't have enough to make 5. So you have to round down to 4. And that's where you get the weird ordered pair. That's why they came up with the ordered pairs of 4, 14 in the back of your book. Wait, if you were getting, you said you had 4.6?
Yeah.
Well, I thought you said you had decimal on that one.
It was like 4.71.
It's close enough. You did it right. If you had if you were 4 and change, you did it right. Was yours 4.6, something like that? It was a decimal though? I don't know what call it was close enough. Yeah. So, like I said, when you have that extra line to draw in that you don't know where the intercepts go, the easiest thing to do is pick one of the intercepted points from the other two that might be on the graph and substitute one of those values of x in to figure out the other one. It's the cleanest way to set those style problems up. Okay? Do we feel better about these now that we've been doing the same thing for 3 days?
What is
Sure. I would like some more practice.
Ordered, 15 came from cover and solve. T intercepted 15, S intercepted 7. I substitute, T is 3S. I substitute here to solve it here. I was using substitution.
No, well, the CE.
He's like,
Oh, the cost? It told you right here. It says you make a profit of $2 on every jar, and $1.50 on that one.
How much do you want?
$1.50, $1, 1.5.
That's a 15.
No, it doesn't. There's a dot there. Okay. So here's what I want to do today. I have 4 more of these. I have 4 more of these on the sheet. Originally there was 5, then I decided, you know what? I'll be 20% nice to you.
you mean 80? 80% mean.
80% mean, yes. And you're an optimist or a pessimist then, apparently.
Guess so.
I'm being an optimist because I'm a Cubs fan. Hope springs eternal.
I dropped that like
But no, what I'm looking at here today is I'm going to give you guys 4 of these. They're very similar in a level of the cabinet problem we did last night, where you have just a couple of equations to worry about. There are a couple of them in here that are straight. Well, I don't want to say straight, but horizontal, vertical. They're a little bit easier to set up. There is one of them on here that I'll talk about in about 15 minutes or so after you guys get started on it, that you have to worry about a secondary parameter that doesn't show up quite often, but it kind of does in this one. So these should not take you the whole period. Okay? If it does, you might have one to do over the weekend, which means you'll probably do it Monday morning.
Monday.
Actually,
Monday
Monday.
Monday
11:07.
afternoon, sometimes around there. So let me get you guys this sheet, we'll go over it.